Okay, so let's get it started with this presentation on the OpenPOWER Summit. So this is my third time joining the OpenPOWER Summit and actually covering some of the same topics, which is something that we are consistently trying to improve as we move forward with power, as we make power easily available, say. And today's my goal is to again give you all an update on what we are doing to ensure that everyone can build on power easily, or better, everyone can get access to power easily. And moving ahead, a little bit about me. So my name is Rafael. I work for IBM from Brazil, and essentially at IBM I have been working with power since I joined about 80 years ago. I started working on most of I would say low level stuff, like developing tools for developers, for other developers. And today I work on the cloud team, where we test and validate and help developing the OpenShift on Power, and also containers. And I have another attributions like Travis on Power, or ensuring that we have Travis on Power running at least I would say at IBM, and then of course helping the community build on Power. So this is a little bit of my background, and yeah, let's get started with the real topics here and how we can make the journey to power easy, and what we are doing and what we are providing today. So at the end of this presentation, you can go ahead and get started playing with your open source project right away without any blocker or any issue. Okay, and why this is important? Why should we provide easy access to power? Why should people, or should developers out there be able to build on power, or have access to power, to ensure they can do their job, and of course ensure that they cover and they play with the necessary, or with the most or with the computer architecture that can fit their needs. So this is not new, but we know that the world is kind of, the amount of open source projects that we have seen are increasing constantly. So and as we move towards a more secure and open platforms, that reflects in the software, and we need to ensure that those new open source projects, or even the closed source, can have access to the resource they need. So if we look, and to keep the pace, and I would say ensure that at the same time someone creates a brand new software, to ensure that they can also add support for multiple architectures, they have the resource they need. So let's take a look at this cloud native foundation example here. This is a kind of, I would say, one of the young foundations that are part of the umbrella of the Linux Foundation somehow. And it's interesting to see that not every day, but if you look at this chart, it's changed constantly, which means that I'll say frequently we have seen there is some new open source project that get graduated and become very highly used. We see new projects that emerge from out of nowhere, and I'd say in few months or days, I would say, developers start to looking at those new softwares and using that as part of their daily activities. And you can imagine that if they do not, so as we are talking about power, if they do not considering another platform instead of just playing with their x86 64 notebook, which is of course the easiest way to get started, we are always going to be behind them. So we need to ensure that those, so here we have just a sample from the cloud, from the cloud native approach. But imagine all the other softwares that are developed, and the amount of change, or the amount, the significant effort that we from Power have in our hands to ensure that when something is created or something is already available, but to ensure that any technology can run on Power easily. So this is hard. We do not have say a lot of people to handle that. We know that resources are limited, so we need to ensure that at least for those playing or willing to play with a different architecture and willing to move to Power, to ensure they can do their job and they can have access to that. Especially because when you see that the adoption of open source comes from developers organically using it. For instance, if you are a developer and you are, let's say, at your home playing with some new cool technology, and you see value on that, automatically you are going to bring that to your daily activities. And probably you're going to influence your coworkers on how cool that technology is and how easily that technology helped you to solve a given problem. And this is what happens. And let's say if you work in a company which offers Power access, and you tried a new cool technology on x86, and that didn't help you out, or if and that new technology helped you to solve a very complicated problem, and you try to move to an enterprise environment where you have Power, and that does not work, so you feel kind of frustrated about that. So we need to reduce these barriers. We need to ensure things work easily on Power, and we need to ensure that the developer that plays with the technology on x86 can also leverage that technology on Power. I would say that so the world is multi-arch, and why they need this capability to leverage multiple architectures, because a given solution for a big problem can involve 2 or 3 different architectures if you know how to combine them. If you need a platform to handle very specific workloads and data intensive workloads, maybe you want to use Power. But if you have a simple service that just needs to be executed for, let's say, a very low priority job, maybe you would like to use x86. So you can combine architectures. You need to learn how to play with different architectures. And I'll say this is a must-have skill nowadays. So we have Power, we have ARM, we have x86-64, we have Z, the mainframe. So developers should be able to play and navigate this set of architectures easily to ensure they can solve the problem using the best approach. So the developer should be, or the development should be multi-architecture. And starting now, I'll tell a little bit of a history of what we have done since I joined IBM on getting Power easily available for others, and to ensure that the migration porting for Power can be done easily. So the chapter one of this talk is going to cover the Power SDK. Back, I'll say 8 years ago, we were working on an integrated development environment where our expectations was so our focus was like, so okay, Power is not easily available back there, and we need to ensure that the developers can run, can compile, can debug, can identify hotspots or look for issues in a source code that targets Power, but we need to ensure they can do that on their x86 64 machine. So, and then, and the work we did with the SDK was much, I would say, focused on that one. We created a bunch of tools like the migration advisor, for instance, that could give you some hints and tips about migration, source code migration, when you are coming from x86 and want to move your application to Power. And also migration advisor also provides some quick fixes. So you really, okay, you should have an idea about what you are doing, but the IDE or the integrated development environment could help you to move forward easily. And of course, as Power was not available, as part of the SDK, we integrated this IBM Power Simulator. Back there, it was IBM Power 8, and then later we added Power 9. I believe that's going to be a new version of the functional simulator available soon for general externally available, covering Power 10. So anyone will be able to play Power 10 using the Power Simulator. Okay, so so at some point we decided to move from the integrated development environment and create a command line tool. So the tool, instead of providing an integrated tool, we started providing tools that could be integrated in a CI environment. So the CLI are open source, so anyone is welcome to try that out. But yes, the SDK was not enough. We understand that back there we had a big software which wasn't easy to manipulate, that could lead to a lot of errors and frustration from the developer from the developer point of view, I would say. So and then this leads to our chapter 2, which is free access to Power. Developers could do cross-compiling and debugging and testing somehow on their x86 64 machine, but this is not it was not the same thing like running a real power resource. So what we started doing back in 2014 was considering providing free access to Power for developers, students, and whoever was interested on starting playing with this but with this platform. So basically we are considering creating a flowery field where developers could get the resource they need. If you are asking why this picture here, but just to give you some idea that our bee here is our developer and the flower are the resources. And this will be important because there's some reference for this in the rest of this presentation. Back in 2014, we started a project here in Brazil called Mini Cloud, which is a partnership with one of the biggest universities, public universities in Brazil. At Mini Cloud, we provided free access to Power. And when we started offering, initially, we received 10, 15 requests. But today we are almost near 2,000 requests, and these are requests from all over the world. So we have people from different countries using that for different proposals for different communities, as also as part of the infrastructure where we host our Mini Cloud. We also have dedicated machines for a given community. Like we have a dedicated Power machine for the Linux Alpine community, so they can do their builds on Power. We have a dedicated machine for Debian, so they can do their testing and validation on Power. And we have a bunch of VMs running there. And people that request access to this Mini Cloud resource, usually they do one of these kind of activities, like they request access because they want to deploy or they want to create software in a multi-platform or multi-architecture software. So they do not have Power available, so they want free. Instead of buying a Power machine in the beginning of the development, so they want to try that out. So they request access for that. They want to enable some technology for Power. They want to test on Power. They just or they want to develop on Power. So they want to integrate Power as part of their CI infrastructure, or they just want to study Linux. We receive a lot of, as we are part of academic kind of academic initiative in Brazil, and also as part of, and Unicamp is part of the OpenPOWER as an academic member. We receive a lot of requests from students who are just beginning their journey, and they asking for access to learn about how to use Linux, for instance. And the very first contact with Linux is Linux running on Power. For us, it's good to offer this kind of access, free access, because free access at some can generate some revenue. So this is an old example, but this is a good example that when we give access to those who really need the access to try Power, at some point they understand that the free resources are no longer available, and they need their own infrastructure. So this was the case with this mono project. They were trying the VMs in the mini cloud, and at some point they saw that the resources were no longer sufficient, and they bought a Power machine. So open source can help some bringing or create revenue. So this is a good example of that approach. But offering resources for free is not enough. We understand that there are some limitations. Probably the environments are not the best fit, or providing a VM is not the way that as a developer would like to access the resource. And as I said, so it's not sometimes the best approach. And this leads us to the chapter 3, which is we need to be where developers are. And this is important because we are in a period of time where CI/CD are one of the most critical part of the development, especially in the DevOps world. We need to be able to write code, test, deploy quickly. So if we are not part of this pipeline, or if we're not a natural part of this pipeline, and we're not going to be part of the supported platform. So we need to ensure Power is there, and whoever wants to try on Power this is going to be very simple and easy for them to do that. And the most used source code repositories we have today are GitHub and GitLab. And those are the places where I believe we must be present as someone offering easy access to some rich platform like Power. So talking first about GitHub, we have enabled Travis CI to build on Power. And also it builds on Z. So Travis CI is still the most used platform for testing open source software. It's very easy to use, and especially if you have your public repository in GitHub. I will show how you can configure your project, but with few lines of code, you can start deploying and testing on Power easily. So as I said, Travis is very, very popular and very used. They continue to grow, and they continue to offer more resources. They are expanding what they are offering and upgrading their backend environment to ensure the users can have access to the latest and greatest solutions or packages and softwares. And to build on Power using Travis, you only need 2 lines of code. Essentially, you need to set that you want to build on Linux, and that you want to build on a PPC64LE architecture. If you set this as part of your Travis.yaml configuration, your build will run on Power without any problem. And how you can do that? So step number 1 is you need signing as part of Travis. And then you need to enable your project there. It's very simple. Just turn on the green button, and your application, your repository will be enabled to build on Travis. Step number 3 is to create a travis.yml file, which is basically a recipe that describes what should happen with your build. As you can see, this is a very simple example, but you can create I would say a very, very complex one, if you will. But as you can see, so I just set OS Linux and Arch PPC 64LE, and that gives me a build on Power. For instance, this is the ski boot of, which is used on our Power machines. They use Travis to build their software. So as you can see, so it cannot, you can do basically whatever you want. When you start to build on Travis, you're going to get a free a Linux VM or a Linux container. In fact, this is an LXD container, and inside that LXD container, you can do anything you want. And once you start building, you're going to get feedbacks about that in your GitHub repository. As you can see, you can follow the build process in a nice shell-like UI in the browser. And yeah, so that's it on Travis. You can start building on Travis right away without any issue. Go to the travis.com, docs.travisci.com, and take a look on the documentation on how you can create multi-chart a build considering all the architecture supported. So you can test in X, Power, and Z at the same time. So a quick example here is that at IBM, we also have Travis on Power, the Travis Enterprise on Power enabled. We started back in 2017. That was required given that we were doing IBM Cloud private development back there. And we needed to ensure development parity between all the architectures, especially because it was a very fast development environment where people were creating code, I would say 24 hours a day. And we should ensure that every code that was pushed to the internal repositories was tested on Power and x86, Power, and Z at the same time. So since then, we have worked to enable this service internally at IBM. And today, any developer that starts using GitHub Enterprise can start building using Travis Enterprise and build on Power. We have more than 1 million builds already since then. So, and we continue increasing this number because we see new projects adopting Travis on Power internally, projects that so people using Travis on Power to build kernel, create CI/CD for the kernel development. So this is very interesting. So this is a good example on how on that when we offer access, easily access to a resource, people start using it, even if they just want to explore it to explore it for some particular reason or whatever. So moving forward, we have also GitLab CI/CD. GitLab is the code platform similar to GitHub, where you can basically GitLab offers a little bit more features if you want to control the end-to-end development of your application. And as part of GitLab, they have a GitLab Runner, which is a daemon, or I can call this a daemon that run in a given VM or bare metal machine. And this allows you to, similar to what happens to Travis, configure a file and start to build on Power, and start to build your application. Turns out that GitLab runs on Power. The GitLab Runner runs on Power, especially if you're trying Ubuntu. To configure that, you need to sign in as part of your GitLab account. And this is the different, where Travis and GitLab are different. In Travis, you do not need to care about the backend. You just need to write your travis.yml recipe. With GitLab, we need to ensure you have a Power VM available or a Power bare metal machine. Today, you can get free Power VMs, a small VM, I would say, in our mini cloud, or you can go to IBM Cloud and get a Power VM in the Power System virtual server, which is available. So you have options to get your Power VM available, and then once you get the resource, you just need to install the GitLab Runner. If we're using Ubuntu on Power, GitLab Runner is available out of the box. It's part of the distribution. There is work going on to ensure that we have the RPM-based distributions supporting supporting the GitLab Runner. But I have built a binary which you can copy to your RPM-based Linux distribution and use GitLab Runner there. Once you have the GitLab Runner server configured, you need to configure that as part of your CI/CD tooling here. Pretty much registering that, you just need these two variables, and the GitLab application that is running in your server will ask for this URL and for this token. So when you set this, it automatically connects the backend with this front end and gives you the necessary pipeline of building. Once you have this communication done and the GitLab master is able to access your, I would say, your worker node in the infrastructure you are providing, you can describe your recipe pretty much like what we did on Travis. This is a YAML file, and the difference here is that I set a tag which refers to my VM. Where I'm running the GitLab Runner, for instance. Once I do that, I can start building on Power from GitLab. So here's I'll say a very simple example that in this example here, I'm using a Power VM, not KVM on Power, but this is a Power VM in IBM Cloud. I'm running a VM in the Power Virtual Server offering as part of IBM Cloud, and there I have a CentOS 8, and inside this CentOS 8 I have my GitLab Runner running in the background and connect to my GitLab man CI/CD infrastructure, and from there I can start building on Power. So without any issue. Of course, as we move forward, I hope to get a more formal supported GitLab for this RPM-based distribution. But this today, the way the things are defined today, we have no blocker to get that done. So again, as we started discussion about GitLab or Power in GitLab, people start to asking about how to use that. And then this guy here approached me asking how to get the resource to do that. And in few hours, once they got access to a free VM in our mini cloud, the guy enabled his application to validate and build on Power. So this is the most powerful example of that. Also, we offer access. People that are really willing to try that resources, they will try, and they will start building and using that. And this is, I'll say, the base on how we can build a healthy ecosystem. Otherwise, so we can provide Power as the most open and secure platform, but Power, this Power without a healthy and living ecosystem is just Power machine. So we need to ensure that developers out there are able to play and use Power whenever they need. And for that, so this is the documentation for GitLab. That will be the presentation next. But what we need to do, I'd say, as we are all interested in Power, we need more Power. And more Power, I mean, ensure that the resources we have available continue to be available, and the resources in public cloud continue, I'll say, can become easily available. More resources, and this is something that we can all do. We can create a simple blog post about how to install a given package or build or compile something on Power, create a tutorial on whatever we want, record videos. So this is something that we need to produce, and that's simple and that's easy to produce, and that helps those newcomers that are starting to play with Power. More advocacy, like we need to do what I'm doing here. Show off your work in conference so people are aware that about what they can do on Power. And more academic outreach. I believe this is one of the key part of the process, because if you stop to start thinking today, every student leaves the let's say they complete their academic journey with a strong background on x86. Sometimes they don't even know that there is another architectures available. We need to ensure that professors and students are aware of Power and they understand and they know the capability of Power, for instance. And for that, we need to approach them, offer access to resource, educate them somehow, and to ensure that when that student leaves the university and they start their professional life, they can take decision where they can consider Power as an architecture to deploy their application. Otherwise, they are going to only consider what they already know, like using the x86 or the famous, or say, the most used cloud provider we have today. So this is what I have for today. So I believe I went a little bit further, but share that you can start building on Power right away without any issue right now. So right after this call or right after this presentation, you can enable your project on GitHub and GitLab and start building as soon as you start building your application Power. So thank you very much. If you have any question, please let me know. If you need any help or assistance trying Travis on Power, trying GitLab on Power, or even if you need free Power VMs for doing your development, let me know so I can, and let me know how I can help you all. So thanks very much.